Introduction. Ordinary matter is composed of atoms that are so small that a single strand of human hair is around 150,000 carbon atoms wide. Atoms are officially defined as the smallest units of matter that are chemical elements, and the 118 currently known elements are listed in a marvelous diagram known as the periodic table. Atoms are not loners, though. Together with others, they form molecules. But how do they form these molecules, and what else are atoms capable of? Atomic Structure 101. The word atom originates from the Greek word atomos, which is defined as uncuttable or unsplittable. The misunderstanding that atoms were the final layer of reality held strong until the 20th century. Through the evolution of atomic theory, we have found three particles that make the atom. The electron is the negative particle that whizzes around the center of the atom. The proton is a larger particle that sits at the center of the atom with a positive charge, and the neutron is the neutral particle around the same size as the proton that also sits in the center. The protons and the neutrons collectively make up the central atomic nucleus together, with the electrons orbiting in layers called energy levels. Each energy level can only hold a fixed number of electrons. There is a maximum number because all electrons have a negative charge, and like charges repel, requiring space between electrons. Since there is a limited amount of space that a single electron shell can supply to the electrons, eventually it will be at maximum capacity. The shells closer to the nucleus have a smaller maximum capacity, while the further shells have a greater capacity. However, the electrons further away from the nucleus are more unstable, as the attractive positive charge from the nucleus weakens over distance. Because of this, all electrons tend to fill out the lower shells first. The outermost electron shell is known as the valence shell, and the electrons in the valence shell are called valence electrons. The number of valence electrons depend on the element. Except for elements that belong to a group called the noble gases, atoms do not have a complete valence shell. Because of a phenomenon called the octet rule, all atoms want to have complete valence shells. This is why atomic bonds form. Ionic bonds. Ions are charged atoms. All of the atoms in the periodic table are electrically neutral because the number of protons and the number of electrons is the same. However, if an atom loses or gains an electron, it gains a net charge. Atoms that lose electrons and become positively charged are called cations, while atoms that gain electrons and become negatively charged are called anions. But how do we form an ion? If an atom with less than 4 valence electrons comes close to an atom with more than 4 valence electrons, then the two atoms go through a process called a redox reaction, where the atom with fewer valence electrons donates its valence electrons to the other atom to complete both valence shells. The first atom will gain a positive charge, while the second atom gains a negative charge. These two unlike electric charges then attract each other, forming an ionic bond. Sodium chloride, or table salt, is a classic example of ionic bonding between a sodium cation and a chloride anion. Ionic bonds form between a metal, which loses valence electrons, and a nonmetal, which gains valence electrons. Covalent bonds. Instead of completely donating and completely receiving electrons like atoms in an ionic bond, atoms in covalent bonds share electrons. Covalent bonds occur between nonmetals. However, this sharing is not equal. Some atoms are more attractive than other atoms, and as a result, the electrons tend to orbit around the stronger atom. The attractivity of this atom is called its electronegativity and forms the basis for intermolecular forces. The slight attraction and slight repulsion of the electrons cause a positive or negative charge in a part of the molecule, written as delta plus and delta minus respectively. Metallic bonds. Metallic bonding occurs only in metals or metal alloys. The valence electrons of metal atoms are delocalized, meaning that they can move around freely. This forms a sea of electrons, and the abandoned atomic nuclei are left with a positive charge. The metal is held together by the attraction between the nuclei and the electron sea flowing around them. This constant flow of electrons means that an electric current can flow through the metal, which is the reason why all metals conduct electricity to some extent. Conclusion. In summary, there are three types of intramolecular forces: ionic, covalent, and metallic bonds. Each of them binds atoms together and eventually builds entire substances. You, your computer, your car, your house, and the entire universe can only exist because of these bonding atoms. This was the third and last remix of our oldest videos that we reproduced in order to fix errors. To enhance your convenience, we have splashed a new look on all artistic designs and reduced superfluous descriptions. If you haven't yet, make sure to check out our 2 other remixes, What Makes You You and The Worst Crime in Human History are the essentials of the Information Institute. Thank you for watching. The second special video of 2023 will air on Christmas. Diving into the guts of black holes and investigating their birthdays, this special video is centered around the mysterious physics of the most powerful objects in existence. Stay tuned for more information.